Hello everyone, welcome to this video presentation on erosion and dilation on binary shapes. In this experiment, we'll explore two fundamental image processing techniques, erosion and dilation, and see how they affect shapes in binary images. We'll understand the concept, the mathematical background, and finally implement it using Python and OpenCV. The objective of this experiment is to create a simple binary image like text or symbol and apply erosion and dilation using various structuring elements. We'll then visually show how object boundaries shrink during erosion and expand during dilation. This helps us understand how morphological operations change shapes in image processing. A binary image is an image that contains only two pixel values, black and white. Here, black, whose value is 0, represents the background, and white, whose value is 1, represents the object. Morphological operations like erosion and dilation work on these white regions to alter the structure or the shape of the object. Morphological operations process images based on shapes using small matrix called structuring element, also known as kernel. In simple words, erosion removes pixels from the boundaries making shapes thinner, dilation adds pixels around boundaries making shapes thicker. Both these operations are very useful in pre-processing and feature extraction in image processing. Mathematically, erosion and dilation are defined as set operations. Erosion is represented as A minus B, which means the structuring element must fit completely inside the object. This causes the object to shrink. Dilation is represented as A plus B, meaning even a small overlap makes the pixel a part of object, so it expands. The extent of shrinking or expanding depends on the kernel size. A larger kernel causes a stronger effect. Now let's look at the implementation using Python and OpenCV. First we have to import the required libraries CV2, NumPy and Matplotlib. Then we have to create a black background image using NumPy and add white text MIT using cv2.putText function. Next we define a 5x5 kernel of ones using NumPy. This acts as our structuring element. Then we have to apply cv2.erode function which is for erosion and cv2.dilate which is for dilation. Finally, we display all three images, original, eroded and dilated side by side using matplotlib. Here are the results from the code. On the left, you can see the original image, the text MIT in white. In the middle, you see the eroded version. The letter becomes thinner because boundary pixels are removed. On the right, you can see dilated version. The letter becomes thinner as new pixels are added along the boundaries. This clearly shows how erosion shrinks and dilation expands the shapes. Now let's look at some key applications of erosion and dilation in image processing. Erosion and dilation serve as basic building blocks for many advanced image processing techniques. They are used across multiple domains such as computer vision, object detection, and even text recognition. The first application is noise removal. Erosion and dilation can remove small unwanted artifacts or distortions from images. For example, if an image contains tiny dots or specks of noise, erosion can remove them by shrinking those regions. After that, dilation can help restore the original shape of the important parts of image. This helps in identifying structural features more clearly. The next, object detection. Erosion and dilation are used to detect object boundaries accurately. They help in separating connected objects and in shape analysis. This process improves segmentation, which is essential for recognizing objects in computer vision systems, such as identifying vehicles, faces, or medical structures in images. The final one is OCR preprocessing, which stands for optical character recognition. In this process, erosion and dilation are used to enhance the clarity of the scanned documents. They make the edges of the letters sharper and help OCR software read characters correctly. This technique is widely used in document scanner and automated reading system. Let's summarize what we have learned. Erosion shrinks the object, removing pixels from edges. Dilation expands the object by adding pixels to edges. Both depend on kernel size and shape. These operations help in noise reduction, shape correction, and image analysis. In conclusion, we have successfully demonstrated erosion and dilation on binary shapes using Python and OpenCV. We learned their concepts, mathematical background, implementation, and real-world importance. Erosion makes an object thinner, while dilation makes it thicker, and together they form foundation of many advanced image processing techniques. Thank you for watching this presentation.